Okay, so as you must have got from Hemant's presentation, that although you are delving into robotics and self-driving vehicles, but still this coding and programming forms the very fundamental part of this entire automation. And why we are learning C programming is because soon you will see as you get into the deeper parts of the workshop that the code that you will be using for the robotics part, that is very similar in syntax and in logic to C programming. And also C programming forms the basis of all other programming languages, so it makes quite sense to learn C programming. So without any further ado, let's get into it. So these will be the various topics that will be covered in this presentation. You'll be learning the basic structure of C programming, the concept of variables and data types, conditional statements and loops, and just a basic idea about functions in C. Okay, so yeah, these are the topics. Starting off with a quote by none other than the creator of C language, Dennis Ritchie, as you can see. So C is basically a structured programming language that enables easy maintainability of code by breaking large files into smaller modules. And these are the four components that C programs are essentially built from. These are variables and type declarations. Type means data type declaration. Functions, which we'll be learning later on. Statements and expressions. Okay, so we mentioned variables and type declarations. Now let's see what they actually mean. Variables. A variable is a data name that may be used to store any data values. So you declare variables to create a storage area basically in which you will be storing the data values. So data types. Each variable in C has an associated data type. Each of these data types require different amounts of memory. So whenever you are declaring a variable, you must specify the data type of that certain variable, because you are specifying what kind of data will be stored in that variable. Like I said, variable is a storage area. So you must also declare the data type. Statements. The statements of a C program control the overall flow of program execution. Expressions. An expression is a sequence of operators and operators that perform a certain action or a combination of actions. Okay. So now this is a code snippet, which is basically the skeletal structure of a C program. So these two lines, hashtag include stdio.h and hashtag include conio.h. These two are known as the header files. This line void main, this forms the entry point of the program, and whatever is written inside these two opening and closing curly braces, as you can see the other statements, these curly braces indicate the starting of the program, and all the other statements that will be within the C program will be written inside these curly braces. So let us look into what each of these mean one by one. Okay, so header files. These two, the first two, like I said, they are the header files. So these are the files which are specified inside the include section. As you saw, they're also specified inside the hashtag include. So those are the header files. And they are precompiled files that have some functions defined in them. So they are given the extension .h. So what I mean by precompiled files that have some functions defined in them is that once you get into functions, you'll see that there are two types of functions. Some are user-defined functions and some are predefined functions. So as you define a certain header file, you automatically get access to certain predefined functions. You don't have to define them later on. You'll be learning them better as you move through the presentation. So the main function. This is the entry point of the program from where the execution process starts. They're compulsory for any C program. So every C program must have that main function. Okay, now let us look into some other functions that are exclusively used in most C language programs. The printf function. In C programming language, printf is used to print the value of the specified data type on the screen. For example, printf alpha will print alpha on the screen. Now, look here, it's written alpha inside quotes. So whenever you are writing inside double quotes, then that won't be considered as a variable. That will be considered as a constant. Like that may have its own data type. Like it's inside quotes, so it will be a string type. So it will be just printing that value out. But on the other hand, if you are printing something like printf %d comma a, then look closely that a is not declared inside double quotes. When you are not declaring inside double quotes, then it will be considered as a variable. And as we saw that variables are storage spaces which already has certain data stored inside them, then that stored data will be declared. Now you might be wondering what is this %d doing here. So that has also been mentioned here. That %d is the format specifier which specifies the data type of the variable whose value is to be printed. So like I mentioned earlier that every variable is associated with a certain data type. So you must specify the format of whatever is the type of the data that is stored inside that variable as you are using the printf statement. So for that, this %d is used. For integer variables, %d is used. So a variable had a data type of integer. %c is used for character data types, %f for float variables, and so on. Okay, now scanf function. Scanf in C programming language is used to read character, string, or numeric data from the user. It is similar to printf in the sense that format specifiers are also necessary here. For example, look at this code snippet. Here's char ch. So ch is basically the variable and char is the data type, character data type. So first we are using a printf statement. So yeah, it's written with inside double quotes. That means it's not a variable. We'll just be printing out enter any character directly to the user. And then there's a scanf statement which is %c. So like I said in the last slide, a %c stands for character. It's format specifier for character and ch. Okay, what is the and ch we'll be seeing? Like this code snippet basically accepts a character from the user and stores it in the character variable ch, which has been declared here. Now this and ch, this ampersand in C denotes address of. It tells the compiler that whatever character value is entered will get stored at the address of the variable ch. So basically, we have declared a variable ch. Now, whatever character is being entered, like after that line printf enter any character, that will be stored in the same address as that variable char ch. Return statement. A return statement ends the execution of a function and gives back control to the calling function. Execution resumes in the calling function at the point immediately following the call. Okay, and now like every main function must end with a return statement. So return statement also form an intrinsic part of every C programs. Comments. Comments in C language are used to provide information about a certain line or multiple lines of codes. Now, accordingly, comments may be single line or multi-line comments. Single line comments are represented by double slash, and multi-line comments are represented by slash followed by asterisk, as you can see here. Now, note that comments do not affect the overall execution or output of the program. So, even if you write a certain single line or multiple line comment, it's just meant to make the user or the programmer understand better that what the programming is doing or that certain line of the code is doing, but it won't affect the execution or the logic. Okay, now from what you have learned so far, we are going to have a look at a sample program. Okay, now it's the basic like every coding, whatever coding language you are going through, the first code that you learn is basically how to print hello world. So now let us start from there. So yeah, as you can see, there are, like I said, these are the comments. Like these are single line comments, and we saw that single line comments are declared using double slash. So see, what I mean by single line comments is that they'll be printing a single line. Like if these both of these two lines, simple C program, two header file for input output functions had to be included in a single comment section. Then it would be we'll be using multi-line comments with slash followed by asterisk. Okay, then hashtag include stdio.h. That's the header file. Then comes the main functions where the execution of program begins. That's the int main part. Now printf hello world. So this line prints hello world and then return 0. We saw that this return 0 is must be there inside the main function, which will return the control of the program back to the calling function. Okay, so I hope this much is clear. Then we should move on. We'd move on to the next plot. Okay, so this is a code for temperature conversion. Okay, hashtag include stdi.h and hashtag include stdlib.h. These two are basically the header files. And then the main function. And in the main function, see, we are declaring two variables here. Both of these variables are having the data type float. So float is basically decimal or point data type. So C and FH, these are the two data types which are having the data type float. And then we are printing the statement enter temperature in Celsius, and whatever value is being entered by the user, that's being scanned, and percentage f is for as form the format specifier for data type float, as we mentioned earlier. And then and c, so and c refers to that it will be stored in the same address as the variable c, which has been declared already. And then the other variable that was declared, fh is its value is calculated as follows. See, you know the equation, right? So that equation only you're seeing here. And fh, basically we're assigning the whatever value is entered by the user in Celsius, we're converting that to Fahrenheit, and that Fahrenheit value is being stored in fh. Okay, and after that, printf the temperature in Fahrenheit is percentage f backslash n. So this backslash n, what it does is basically it adds some space or prints in the next line. So you could also use something like endl, but yeah, backslash n. When we'll be printing this code out, we won't be seeing backslash n. We'll be just seeing that the fh value or whatever it is, it will be printed in the next line. So temperature in Fahrenheit is percentage F, because FH is having data type float. And then FH, it will print the value FH and return 0 like you saw. Okay, now moving on to conditional statements. Conditional statements are used to execute a set of statements based on certain conditions. The specified condition is first checked, and then if that condition is satisfied, the following set of statements are executed, otherwise the body is skipped. So if that specified condition is not satisfied, then the following bodies of codes are not executed at all. So there are various types of conditional statements. Like if condition is the simplest conditional statement, which executes a set of statements based on a given condition. The condition must be a Boolean type expression. What is a Boolean type expression? A Boolean expression is one which returns only true values, either true or false. So here you can see the flowchart of if statement. So the flow of the code comes to the test expression. So now once the expression is tested, which is basically the condition, like, and it you can see that there are only two possible values, true and false. Like you said, it will be a Boolean type expression. So if it is true, then that body of if, like whatever will be following after that condition, that will be executed. And if it is false, then we are not going to that entire body. That body is not executed at all, and we are just moving to the statement just below if. So like we said that the body of course will not be executed at all if that condition is not satisfied. Okay. Now, based on what we learned in the if condition, it's a simple code. The header files, the usual main function, and then we are declaring a integer data type. Variable name is number. So okay. So printf enter a number. The user will be entering a number. It will be scanned as and number. Its value is assigned to that address of number variable. And if okay, now here's a comment. The test expression if number is less than 0. So if the entered number by the user is less than 0, that is if it's negative, then you are printing you have entered the number. You'll be printing the value of the number whatever the user has entered. However, if it's positive, then you can see that just this printf line, it won't be nothing will be printed, and the code will just end, because we'll move to the return function directly, and the entire body of the if function will be dodging that. Okay, I hope it's clear. Now moving on to the next conditional statement, if else condition. Now, if else condition is known as double blocked conditional statement. It means it has true parts as well as false parts. So as we are seeing in case of if condition, that if that statement is not like there were two branches, true and false. So if that statement if that condition is not satisfied, then nothing was being executed, right? We're just dodging that entire body of the if statement and moving on to the next part of the code. However, in case of if-else condition, there are you can look at the flowchart that there are two prongs. So if the condition is satisfied, then like the body of the if statement will be executed, and if it is false, then the body of the else statement will be executed. So either way, something will be executed. Like unlike that of if statement, if it was false, then nothing was being executed. Okay, so like that's what's been said here. If the given condition is true, a certain set of statements is executed. If it is false, another set of statements get executed. Okay, now let us look at another sample code. Okay, the header files and the main functions. It's actually the initial lines are similar to the previous code. Int number, printf enter number and number. Okay. Now look here. We are seeing a new operator, that is enter number percentage 2 equal to double equal to 0. Okay, so double equal to is basically the same as like what we use equals in like traditional mathematics. And in case of coding, the single equal to will be the basically assignment, and double equal to will be used to check whether the value is equal to, like in the traditional sense of that sign. And here this operator, this percentage operator, you can see the comment part there. The percentage is the module operator which returns the remainder value upon dividing by an integer. So that number, whatever is being entered by the user, it will be divided by 2, and what like if it's even, then there will be no remainder, and if it's odd, then whatever is the remainder, that's basically 1. So that will be given. That will be like this number percentage 2, what that 1 will be basically the value if it's odd. So if there is no remainder, then you will be printing that the entered number is an even integer, and then you'll be printing the value of the number. And else means that if it's odd, then you will be printing that it's an odd integer. So yeah, it's pretty simple. And as you can see here, that there are two blocks of statement for both if and else. So if the condition is satisfied, then it will be printing its even integer. Else will be printing its odd integer. Okay, moving on. Yeah, so the next comes nested if-else condition. Usage of one if-else statement within another if-else statement is known as nested if-else statement. Now you can look at the flowchart that there are two conditions. So if the condition 1 is false, then a certain statement, statement 3 is executed, and directly we are moving on to statement n. But if it's true, then instead of executing another statement, we are going to check another condition, which if that second condition is true, then a certain statement will be executed, and if it's false, a different set of statements will be executed. So like the true or false doesn't directly lead us to separate blocks of statement. Like either one of the condition, or it may be that both of the conditions are leading to different conditions. But at least one of the conditions must, at least one of the true or false parts must lead us to one condition to make it a nested if else condition. Okay. Now moving on to the sample code. So int ab, two variables a and b has been declared, which data type is integer. Enter two numbers. The user enters two numbers which are assigned to the variables a and b. If a equal to b, means if the value of a and b are equal, so printf the two integers are equal. Else if a is greater than b, printf. So here you see that if like in the flowchart, if condition 1 is true, so here if it was false, we are moving to a statement. Now in the code, if it's true, then we are printing this statement, and else means if it's false, then we are being leaded to another set of conditions, if a, b, and else. So, like if they are not equal, then if a is greater than b, printf the first integer is greater than the second integer, else printf second integer is greater than the first integer. Okay. So this is an example of nested if else condition. Now switch case condition. It is a multiple condition checking statement which is generally used for menu driven program where we have to select one option out of several options at a time. The number of case, like in switch case, the number of case within switch statement is same as the number of options present in the menu. So look at the flowchart to get a clearer idea. So there's a single expression firstly, and like that will be the switch part, and then there will be case for each. So like case 1, case 2, case 3. So case 1 will be basically checking whether the value of the expression is equal to the constant 1. If it's yes, then a certain code block will be executed, and then we'll be getting to the return statement. If it's no, then we'll be checking whether its value is equal to case constant equal to 2. If that's true, then we'll be executing code block 2 and then to the return statement. If that's not true, then we'll be checking whether its value is equal to constant 3, and then similarly we are going. Now look here that there's a default code. So this default is basically an optional part that if none of the mentioned cases are satisfied, then like if there is no default statement, then we'll be getting an error. So that's basically an error handling part. So if none of the given conditions are satisfied, that default statement will be executed. Okay. So here's a very simple example of switch case condition. INTA, uh, printf enter day number. So whatever day number the user will be giving, that will be assigned to the value of the variable. Now switch A. So we'll be dealing with the value of the variable A. So case 1, if the value of the variable is 1, printf Monday, and then break. So like here you can see in this comment, we are mentioning the function of the break statement. So break is a keyword in C which is used to bring program control out of the loop. So like once we are saying break, then it moves directly, like we have already printed Monday, so we don't need to check any further conditions. So we are directly getting out of the loop. Okay, but if is not 1, then we'll be checking if it's 2. Like similarly, we'll be moving on up until 7. And if all of that is not satisfied, then if someone has like something like more than 7 or 0 maybe, then we'll be printing this default statement. So like I said, optional section meant for error handling. And the default, it will be printing that the day is not valid. And then backslash n means we'll be moving on to the next line. Now let us look at the basics of functions in C. What are functions? Functions in C can be defined as a block of statements which perform a particular task. The main is the driver function in every C program. As you saw in the previous course, there was always a main function. Okay, functions have a predefined prototype. The same function can be accessed from different places within a program. Once a function execution is completed, the control of the program returns to the place from where the function was called. Now, yeah. So what are the advantages of using functions? They enable modular programming approach. So what is modular programming? It means that subdividing a computer program into separate subprograms. So as we mentioned initially in C language, so one of its features was that it was breaking up a larger task into smaller tasks. So function helps us fulfill that criteria as well. Okay, the length of the source program can be effectively reduced, and functions are easy to locate, and faulty functions can be easily isolated during debugging. Functions can be used by other programs as well. Okay, you'll be seeing how these are satisfied as we move on. Okay, I have already mentioned this that there are two types of functions, built-in functions and user-defined functions. Built-in functions are also known as library functions, and they are written in the header files like I mentioned them. And to use them, appropriate header files need to be included. For example, stdio.h header file includes the functions printf, scanf, getchar, etc. And other than these, there are the user-defined functions. They are written at the time of programming by the programmer. So in case of built-in functions, now, as you have seen in the previous programs, we are never actually defining what printf would do or scanf would do. We just we are acquainted with their usage, and based on that, we use them as and when we need them in the program. But on the other hand, in case of user-defined functions, we must define what that function would be doing. And as we define that functions, accordingly, we will be using them in the code. Okay, now the four elements of functions. The four basic elements of functions are the function prototype, function call, function arguments and parameters, and function definitions. We'll be looking into each of these elements one by one. Okay, function prototype. It specifies the type of value that is to be returned by the function and that is passed by the function. It is defined in the beginning before the function call is made. So what is its syntax? Its syntax is return type. So return type is basically what type of value it will be returning. Then the name of the function. So as you can see in the example, so void, we are not specifying what type of value to be returning. So it encompasses almost, it can include integers, characters, floats, whatever. Name of the function is sum. So here's the name of the function. And then within double parentheses, we'll be declaring arguments. So arguments, what are arguments? We'll be seeing. Okay. Okay, yeah, we'll be seeing in the following slides what are arguments. As you can see that the sum function will be dealing with integer, two integers. So it has two arguments, both of which will be having the data type integer. Okay, now moving on, function call. A function can be called by specifying name and list of arguments enclosed in parentheses and separated by comma. If there are no arguments, then empty parentheses are placed after function name. And if the function returns a value, function call is written as assignment statement. So what is assignment statement? Like I mentioned earlier, that when we're using single equal to sign, then it becomes an assignment statement in coding. So here's an example that this variable a will be getting the value sum xy. So based on two other variables x and y, or like these are basically the parameters, parameters or arguments. So operating on them will be this sum function, and based on that value, whatever is that value will be assigned to this variable a. Okay, this there goes function call. Now function arguments. So here we'll be looking into arguments and parameters both. Arguments are also called actual parameters. They are written within parentheses at the time of function call. So arguments are mentioned during the time of function call. And parameters, on the other hand, are referred to as formal parameters. Arguments were actual parameters, and parameters are formal parameters. And these are written within parentheses at the time of function definition. So arguments, while they are mentioned during the time of function call, parameters are written during the time of function definition. Okay, so moving on. What is function definition? It's the independent program module which is written to specify the particular task that is to be performed by the function. Yeah, the first line of the function is called function declarator, and the rest lines inside these curly braces are called function body. Now, it will become more clear if looking in this code snippet. So here are the header files. Then look here that void sum int. This forms the function prototype. Okay. Now we have not yet defined what this function sum would be doing. So like, but let us first look into the main function, the usual main function, int ab printf. Now we are accepting the two integers and assigning their values to a and b. And then we are using that sum function, which we'll be defining later on, to calculate the whatever like will be the usage of the sum function to operate basically on the two variables a and b, and then we'll be returning that value or whatever. So now let us look into what that sum function will be doing. Here we are actually defining the sum function. So sum function has two parameters, int a and int b. As you can see, these are the parameters, and when inside the main function we are saying a and b, then these are the arguments. Okay, so void sum int a int b, and then printf the sum of the numbers you entered is a and b, a plus b. So this sum it will be printing this, the sum of the numbers you entered is, and then it will return the sum of the two entered variables. Uh, okay. Mm, I hope this is clear. Then goes the return statement.
Yes, Bhaiya,
It is
can
the.
you explain that how can we call a function?
I'm sorry.
I want to ask how can we call that function?
How can we call a function? Okay, so look, sum AB. Whenever we are writing this line, this becomes a function call. Like we have accepted the two variables a and b from the user. We have accepted two integers and assigned them to a and b, and then we'll be dealing this with this function sum ab. We are writing this statement, right? This statement itself is the function call. We are calling the function sum, and that sum to call a function we need to define it, and that function definition has been done in the in here, right? Is it clear?
Yes, Bhaiya.
Okay. Return statement. So it is the last statement of the function which returns certain values. Its syntax is return followed by variable name or constant. Okay. Yeah. Now let us look into like based on arguments and return types. We just saw return and we have seen argument previously. So based on that, the functions can be categorized into four types. So these four categories are function with no argument and no return type, function with arguments and no return, function with no arguments and return, and function with both arguments as well as return. Now we'll be I won't be like defining what are these. You have already seen what is arguments and what are returns. So based on that, we'll be directly looking into the codes. Okay, so this is the first type, that is no arguments and no return. So yeah, okay, look, the usual goes, then there's void sum. As you can see that there are no arguments mentioned, and here also void sum, there are no arguments. There are no arguments or no parameters either. Okay, so now here's the main function. We're just calling the sum, and okay, get ch, like you might be wondering where I have not mentioned get ch in the presentation. So here's this comment part. It pauses the output console until a key is pressed. So basically its usage is similar to the return zero part. For now you can think like that. It pauses the output console until a key is pressed basically. And okay, so this sum function has been called here, and now we are defining the sum function, that void sum. Like I said, there are no arguments or parameters, and then int a b. So two variables of data type integer are being declared. Then printf enter two integers. Then those two integers are assigned to the two variables, and then we are printing the sum of the two numbers entered is a plus b. So this is an example of no arguments, like I said, and no return as well. Now the second type is with arguments but still no return. So here you can see the void sum int. In the previous code there was nothing mentioned as such, and here also there was no parameter int b, nothing was mentioned. We are directly accepting integer a b here. So here we'll like since there was no arguments, we could not accept the value of the variables in the main function.
Uh,
We had to define
in
that in the function.
this code, we can use a get character in place of return zero always.
Um, yeah, I mean, from like whatever code we are looking into at this basic stage, you can think that those two are interchangeable. There won't be no issue.
Okay, sir.
Yeah. Okay, so where was I? Okay, function with argument and no return. So yeah, as I was saying that there are void sum int. Like here you are fixing the arguments and the parameters. Like when you are defining the function also, then you are mentioning int a, int b. But on the other hand, here there was nothing as such, and as a result in the function definition itself you had to like assign those two variables and accept as well. You could not do that in the main function. But since we are defining the arguments as well in here, so we can do that in the main function. So here in the main function we are doing, yeah, int a b, printf, enter two numbers, scanf, and a and b. Now this sum a b, we are calling the function sum, and which has been defined here, void sum int a int b, printf the sum of the numbers you have entered is a plus b. The rest is pretty much the same. The only difference is that this int part, like which is the argument, which it was not there in the previous code, it's mentioned here, it's included here in this example. And but still it does not have any return type. Now you'll be seeing following code that there is a return statement, but it has no argument. So yeah, as you can see that void sum, there are no arguments mentioned here also. Um, Okay, but like look here, that in the definition of the function sum, after we are assigning the value of the integers to the two variables, then we are returning a plus b. So there's a return statement, right? Which was not there in the last two codes. So as a result, we are saying that a function with no argument and return. And then printf the sum of the numbers is like this part is basically the same, x equal to sum int x equal to sum. So the value of the variable is whatever we are getting after computing a plus b, that's being assigned to that, stored in that variable, and then the value of the variable is printed. Okay, and then comes the final category, that is with both arguments as well as return statements. So here are arguments int int and int int b, like I mentioned earlier. And now you can see that in the definition of the function also, we're just returning a plus b. So there's a return statement as well. So there are both arguments as well as return statements in this category. And this part is same. So yeah, here in place of two variables, we are defining three variables in the main function, and the third variable is getting the sum of the other two variables basically, and that's being stored in the third variable, and then we're printing the value of the third variable. So yeah, we have covered all the four categories. Now we'll be looking into the methods of calling function. You have already seen function call, like, right? So like it can be done in two ways. One is call by value and one is call by reference. We will be looking into each one of these. Okay, so call by value. Here the values of the actual parameters are copied into the formal parameters. Um, During execution, whatever changes are made in the formal parameters are not reflected back in the actual parameters. So like we can make any change in the formal parameter, so it won't be affecting the actual parameters. So it won't be reflected back in the actual parameters. It will become clearer with the code. So here's an example of call by value sample code. Um, yeah, so this line swap AB, this is basically calling the function. And we are just calling by arguments like A, B. So as you see, as you have seen in the definition. So and yeah, here also there is int A, int B. So like this is a traditional example, like whatever I've seen already, that was call by value itself in the previous examples as well. So you are quite familiar with call by value, but now look into the other category, which is call by reference. So in here we are not directly passing the uh, like parameters. Here the reference of the original variable. What is reference? Reference is basically address, and we have already seen how we call the address. That is basically using the ampersand operator, right? We have seen in case of scanf. So reference or address of the original variable is passed. Function does not create its own copy. It refers to the original values by reference. But look here that the function works with the original data and changes are made in the original data itself. Okay. So here's the sample code for that. Yeah, so as I was saying that this line swap and a and b, this is basically the function call. So this is ampersand a ampersand b. In the previous examples, we are directly calling a and b in the arguments. But here we are calling the address or basically the reference. So whenever we're using like this call by reference method, Then we have to use pointers. So this int star a, int star b, that's basically the pointers. So what is pointer? Basically, pointer point like whenever you're calling to the address, it has to trace back to that. At whenever you're using reference, it has to trace back to the address of that variable, and pointer will be pointing to that address as well. So it traces back to the basically the pointer. So okay, the rest of the part, clear screen. This CLR SCR is basically used to clear the screen and enter the two integers, and we'll be assigning the two integers to the variables a and b. Okay, and then printf a and equal to a b equal to, and yeah. So like percentage d, like the first percentage d is for the value of a variable, and the second one is for the value of the b variable. Then swap and a and b, and that function will be called, which is defined later on. And then the value is printed before calling the function, and after calling the function also the value is printed. And then there is get ch.
Here pointer int and int pointer both are same or what?
um no, both are not same. Like in this example, it's int pointer, so it's basically like we have declared the pointer type is integer, and that's like int a, and that entire thing, that a variable is a like that pointer to that variable. Now here we're declaring the pointer type is integer. Are you getting it? Like we are saying asterisk k, and then that's being set integer. On the other hand, if you are saying asterisk inta, then inta is the basically the pointer.
Yes, bhaiya.
Is it clear?
Got. Yes,
Yeah.
yes.
Yeah. Okay. So int star a, int star b. Yeah. Uh, then there's int temp. Temp is assigned asterisk k initially. Then the two asterisk k equal to asterisk b, and asterisk b is then assigned temp. So what is happening, that this variable temp, it's being assigned the pointer to a initially, and then the two pointers. So the pointer a is being replaced by pointer b, and then the pointer b is assigned to temp. So what will happen is the a and b values will be swapped. As a result, this is called the swap function. And then a equal to and b equal to, so whatever the value was printed before calling the function a and b will just be interchanged after calling this function swap and b. Okay, so this is all. Thank you. And now, from whatever you have learned, basically this function by call function, calling by value calling by reference, this entire part won't be of much usage in case of the other parts of the deeper parts of robotics, but this will give you somewhat of a brief idea of what type of code you might be dealing with while you are delving into robotics.